Let's look at permutations with some identical items. So looking at the number of ways you can arrange letters of a word, let's compare a word with 4 different letters, a word with 2 of the same letter, and a word with 3. So the first word, dole, all the letters are different. So you can arrange that word in 4 factorial different ways, otherwise known as 4p4, which will be 24 different ways. When you're looking at the word doll, things change a little bit because you could arrange the word doll in a way that's the first arrangement and this is the second, and they're indistinguishable from the other unless you start using subscripts. So that's L1 and that's L2. Then of course you can switch those around. But without the subscripts, you can't tell one from the other. And so we have to have a way to account for that difference. So the number of ways you can arrange 4 letters is 4 factorial. But to account for the fact that we have 2 L's, we're going to divide it by 2 factorial. And that will account for all the different ways that those 2 L's show up in the word doll. So those are 2 different arrangements of doll, but they look the same. And again, you can put them here if you want. Those are 2 different ways of arranging the L's, but again, they look identical. So what you do is you take the identical items and you divide those out. So 4 factorial over 2 factorial will equal 12 different ways. Now the same concept can be applied to the word lol. In this case, 4 letters, 4 factorial ways. But because you have 3 of the same, you divide that out, and that equals 4. Now let's look at tile patterns. So Tanisha is laying out tiles for the edge of a mosaic. How many patterns can she make if she has 4 yellow and 1 each of blue, green, red, and gray tiles? So 4 yellow, 1 blue, 1 green, 1 red, and 1 gray. So you've got 8 tiles total. So you can arrange those 8 tiles in 8 factorial ways. But because you have 4 yellow tiles that are indistinguishable from each other, you account for that by dividing 4 factorial. And so the number of ways you can arrange them that are distinct is 1,680. So far we've looked at just taking out 1 repetition. In this example, the word bookkeeper is unusual in that it has 3 consecutive double letters. So how many different ways can you arrange the letters in bookkeeper? 3 consecutive double letters. So we've got a couple of O's, a couple of K's, a couple of E's, but then we've got a 3rd E hiding over here. So in this case, there are 10 letters in bookkeeper. To account for the double O, we divide by 2 factorial. To account for the double K, we divide by 2 factorial. And to account for the fact that we have 3 E's, we divide by 3 factorial. A couple of different ways to do this, but just to illustrate, 10 factorial is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 3 factorial is the 3, 2, 1. So those are going to cancel out. 2 factorial is 4. And so you just have this left to multiply through. And that value is going to be 27,720. You could also look at the remainder and say, you know what? That is 10p 1, 2, 3, 4, 5, 6. And you'll get the same result. Thanks for listening.